Okay, so we have listed years that archbishops and monarchs lived after the election or coronation, and we're going to test at 0.10, so 10% significance level, that the longevity of archbishops, so our mean 1, is less than mean 2, are monarchs. And I always write that down, otherwise I get myself confused with which one I'm doing. So we know that our null is always equal, so it has to be C or D, and I want that the archbishops live shorter, so this one right here. Okay. Now I'm going to do this in Excel, so I'm going to open up my data. I'm going to open up my data in Excel. Okay. And once this gets open, I'm going to get this open. And my other video shows you how to do this kind of piecemeal, do all the pieces yourself. I'm going to show you how to use the data analysis tool in this one. So I'm going to go here to data, data analysis, and I want to go down here to this t-test with unequal variances. So my variable 1 is A1 through A25, and then this is B1 to B13. I'm hypothesizing that there's no difference. Labels, and I'm going to change this to 0.10, and my output, I'm going to just put it in K1. Okay, so this is all my information. Okay, so now right here, there's my t-stat, so that's coming right here. So negative 2.83. And then I need to look up my critical value. So my smaller df, so to find my cf, my df is going to be 11. I'm going to go with the smaller one. And I've got a point. So I like this. You can see here, this is area in one tail is 10%. Go down to 11, 1.363. 1.363. Now I could have also then, if I was doing this two-tail, a confidence interval, it's really 20%, remember, because of the same. Because it's a one-sided test, when I replicate as a confidence interval, I need 10% in each side. So I'm actually doing a 20% confidence interval, or 80%, because I have to have the same amount in each. So 0.10, 0.20, they're lined up here. I like that, but you can of course do this in Excel as well. You just need to make sure. I like the visualness of the table. So now, to find the confidence interval here, they're going to give us, and you can see actually that's pretty close, but they did their DF a different way. You can use that if you want. I think it'll probably work, but this is the way I've been doing it, so this is the way I'm going with. And I need to find my error value. And so now to find my error value, okay, I'm going to do this in two parts here. First, I'm going to do what's under the brackets. When I look here in my confidence interval right here, 2 means, this error, I need this whole stuff under the radical. So square root, and then I need the S2, so standard deviation squared, which is variance, which is actually what they gave me. So I want L5 divided by L6, I think, and then plus M5 divided by M6, okay? So that's under my square root, and I'm going to take that, which is F7, times my CV, which is F4, and that's my error value. Now I need to find the difference of my means, so that's simply L4 minus M4. And then I come here and so I want my lower and my upper. So my lower is my difference, F10 minus my error, which is F8, and this is F10 plus F8. So my values are negative 5.245 and negative 1.838. So coming back over here, I have negative 5.245, negative 1.838, and yes, it supports it because it's only negative values. So it's always less the first one. Let's see here. It doesn't want me to check my answer. 1 second. What didn't I put in? Oh, so I did say this. So reject. There is sufficient. Okay, so I forgot to go back up here. So I forgot to do this part. So when I found my test statistic, I looked up my critical value. Then I forgot to go back and look and see what it means here. But this is 1.363. So that is, and we look, since we're doing less than, we look at the negative, and my value would have to be less than negative 1.363. It is, so I reject. I do have sufficient evidence. And now check my answer, and you can see I got it correct. So when you're doing this, this will do it for you, but remember that when you're working with this, this is variance. We're used to seeing standard deviation, and they did put variance here. So that's something to watch for as you're calculating the formulas.